Okay guys, let's try again. There was a bit of music problems in the background, so make sure that you share this live. Let's give it another few minutes, because I haven't done a live in a very long time, so haven't done these lives in a very long time, so make sure that you share this live. We're gonna do paper 2 revision. Maybe I should just make a note of it. Guys, as you can see, it's a little bit rusty. Haven't done these lives in a very long time. Trying to read comments. I have a MacGyver type of. Not sure if you guys can hear me now properly. Trying to read the comments. I am connected to my laptop as well, because I'm not sure if I'll be able to see the comments there as well. The TikTok live has changed a lot. Just let me know if you can hear me clear for those who are listening. Yeah, on my laptop it's upside down, so I can't actually really see clear enough what's happening. Let's see. Also, it will help a lot if you can double tap the screen and share this live, so that more grade 12 students, I assume most of you guys, if you're watching, you're at home doing some revision, because your finals will probably start in the next 2 to 4 weeks. So make sure that you share this, whoever needs help. So we're going to work through question paper. This is 2018 November paper 2 that we're working on. We're going to do a few questions. This is going to be our 50 to 60 minute session. So we're going to end at 3:15, because that's how I time it, other stuff to do. So make sure that you share this live as well. is besig. Thank you very much for sharing, Tarina. Your name looks so familiar. I think you've been on my live was it last year? Yeah, because that's the last time I did a live. Thank you very much for the like. So that's going to help a lot. Okay, so let's jump into the first question. Question 3. The questions that I set up for today is paper 2, as I've said, and it's going to be trigonometry, and we're trying to do, Euclid, analytical geometry, circle geometry, well, let's rather say analytical geometry, and then trigonometry, and then obviously we want to do a little bit of Euclidean as well. So let's look at it. Thank you very much for sharing, and also the likes. It really helps a lot, not because I want the likes, it's just so that more students can be aware of these live sessions. So the first question they ask here is in the diagram. Not sure if you can see it clear. Just let me know if you can see it clear enough, because I'm seeing other stuff on my laptop. According to my cell phone, if I look from above at my LCD or at my screen, it's clear enough. But yeah, so let's look at this question 3. It's stated here in the diagram ABCD is quadrilateral having vertices A, so here's the point A, and B, here's the point B, and C, here's the point C, and D, there's the point D. Now they want us to calculate the gradient of AC. So we need to calculate this gradient here, AC. So obviously you need, so this is the advice I give to students. But this is the advice, and I'm going to give you, because this is a 2 marks, this is worth 2 marks. I'm not going to give you a lot of minutes to do this, because this is my process, number 1. My process is, I read the question, and I give you, in this case, I give you a few minutes, and then we can do it together. So it's important to have all your material ready, your pen, your notebook, your calculator, your eraser, your highlighter, whatever the case may be, because it's not a movie, it's not entertainment, it's edutainment, okay? So I'm going to give you a few minutes to calculate this one, and then we're going to work through together. So I give you that few minutes. I just quickly have to check out something important urgently. Okay, so if you have an answer, you're more than welcome to comment the answer as well. And that way the lesson will be more interactive. I can ask you, okay, how did you get that? All that jazz. Okay, so let's get it. So yeah, so this is the second thing that I want to mention here is, yes, you're going to need your gradient formula. But remember, when it comes to these formulas, yes, you're going to get it on the formula sheet. It's going to be really challenging at the end of the day because you're going to lose a lot of time. If you're going to flip up and down and look at the question paper, excuse me, at the last sheet where the formulas are located. So that's going to be a problem for you. So that's why I always suggest, okay, know these things by heart. So the first thing, like I said, is get out the pen and paper and also the formula sheet thing. Okay, so 3.1. So I'm gonna write here. Hopefully you guys can see what I'm writing. Let me see. Yes, I think it's okay. Okay, so it's 3.1. I think this pen is okay. Okay, that's the best I can do. Hopefully you guys can see what I'm writing here. So somebody say Tarina's got a half 1/2. Okay, let's see if you're correct. Guys, this is a very uncomfortable setup. Okay, so the gradient of AC equal to, as you know, it's y2 minus y1, everything over x2 minus x1. So here your x2 and your y2, it can be anything. Okay, so this can be your x1, your y1, and this can be your y2, x2, y2, or vice versa. It's really up to you. So just because I have this, these values doesn't mean yours are incorrect. So I'm going to say this is going to be my x1 and my y1 and my x2 and my y2. So it's going to be 1 minus, so it's minus 4 because this value is negative, so there we go, that's my y1, and my x2 is going to be 7 minus 7, okay, there we go. So if you type this in your calculator, you're going to get 1/2, and this is your final answer. Okay, so well done to Tarina. Okay, so that one was 2 marks. So let's look at the next question. The next question asks us here, we need to determine the following two things. 3.2.1. We need to determine the equation of AC in the form y equals mx plus c. So we want the equation of that line there. So there's a invisible line that I haven't drawn, okay? So that's going to be 3.2.1. They want the gradient of, excuse me, the equation of this line. There's two things that you need. You need the gradient of AC. We already calculated that here in 3.1. The second thing that you need to get the equation of that line is a point on that line. So it's really up to you. The important thing here is the point must lie on between A and C. So, why did I say A and C? So you can either use this or this one. I'm trying to avoid saying A and C because it's making me nauseous saying that. So I'm going to use the point, let's say 1 and 7. So I'm going to use the point A. Oh, before I do that, let me give you a few minutes. This is 2 marks worth. I want to see if you get the answer. So before I start off with this question, doing it with you guys. So the question here is the equation of AC in the form y equals mx plus c. If you have the answer, you can just double tap the screen. That will also help more students, grade 12 students, to see this live session. And also, obviously, it will appear in the For You page of TikTok. Okay, so 3.2.1, they want us to calculate or determine the equation of AC. It is a straight line. To get the straight line, there's two things that you need. It is the gradient, so the gradient of AC, and also a point or one of these two coordinates, but the point must lie on the straight line. So like I've mentioned before, you will need excuse me, I'm going to use this point here, and obviously you need the formula to determine the equation of the line. So there's many ways that you can do this. I like using the one y minus y1 equal to the gradient open bracket x minus x1. Okay, so there's this other one, y equals mx plus c. You can do that as well. So y, that's going to remain the same. Going to use substitute 1, okay, where I see y1, so there's going to be a 1 equal to my gradient, so it's obviously the gradient of AC, so we determine that it's going to be a half, so it's a half open bracket x minus x1, the x value is going to be 7, so it's going to be 7, close the bracket. And if I simplify this, before I skip steps, I'm just going to write down everything. So it's y minus 1 equal to half x minus 7 over 2. So that means the equation of this line AC is going to be y equal to half x minus 2.5 or 7 over 2. It's really up to you. You can leave it like 7 over 2, but this is your final answer. Whoa, wait. Now I need to do this. This is a new setup, so I'm struggling a little bit. But don't worry, I'm going to run through this answer again. If you got that answer, you can double tap the screen, but if you have a question, let me know. Like, just to give you a view of the setup that I'm currently have. So I have a stack of books in front of me on my right side, so on this side, yeah, and then it's a stack of books, and then between the books there's a ruler, and to that ruler my cell phone is stuck to it, so it's really uncomfortable, and the cell phone is eye level, like that height. Okay, so let me just run through this question again. They want us to calculate the equation of AC. So this is a straight line. You need two things. You need the gradient, and we already calculated the gradient in this question here, the first one. And then also we need a point on that line. Okay, so it can be C or A. I'm not going to say A and C again. So it can be C or A. And then obviously you need the equation, the formula that you will get on your formula sheet to determine the equation of the line, which is this one. So I said, okay, I'm going to substitute this coordinate A into the formula. Wherever I see y1 in this case, I'm going to substitute my y, the 1 value, so there's it. And then also my x is 7, so there's, instead of x1 I have 7. Okay, those are the values I substituted into it, and then I simplify this a little bit, and this is going to be my final answer. So let's get to the, let me just refresh my laptop a little bit. So let's get to the next question. They want us now to determine whether M lies on this AC. Okay, and this one is worth 4 marks. This one is worth 4 marks, and I want to know now what we need to determine whether M lies on AC. So I'm going to give you 2 minutes to do that, and then we're going to jump straight into it. I'm going to do it with you guys. if you have the answer, make sure that you double tap the screen, or you can just comment your answer, or you can just give me a thumbs up if you think you have the answer. If you have any other question related to this question, you may ask as well in this comment section. I will read. Try my best to read. Like I've mentioned, my screen is upside down. Okay, so yeah, in this question, just remember the thing about analytical geometry is most of the times, 99% of the times, it is where you're going to need the previous answer. Okay, the previous answer, and if you get that wrong, all of the other stuff will be wrong. Most of the times it's like that. So as you've noticed in question 3.2.1, they ask us to determine the equation of AC. And here we needed a gradient of AC, and we already calculated it here. So as you can see, it's really important. Okay. They ask us, we need to determine whether M is on this, lies on AC. So there's basically two ways you can do that. I'm going to just show you the one solution. And basically, remember in the beginning of this whole question, they said M is the midpoint of BD. So here's BD. So this is a quadrilateral, by the way. So they must share the same midpoints. Okay, so the midpoint of BD is equal to the midpoint of AC. So the first thing, obviously, that we need to determine now is calculate the midpoint. So to do that, you need the formula for midpoint. Okay. So that will be the next question. I'm just gonna move my book up a little bit so that you can see. There we go. So this will be question 3.2.2. We just do this. Hopefully there's enough space here. So 3.2.2. You just see if it works. Need the formula. We're going to calculate the midpoint. So let's see the midpoint of AC. Supposed to get, so the midpoint of AC is the same as the midpoint of BD. So let's calculate the midpoint of BD. Okay, so I'm going to say midpoint of BD. The formulas say it's going to be x1 plus x2 over 2, and we also take the one y value and add it to the other y value and divide it by 2. Okay, so let's do that. Substitute this point, so it's going to be BD. So like I said before, it doesn't matter which one is x1 and x2, it's really up to you. So it's going to be this x value plus that x value divided by 2, so it's going to be negative 2, we just do that block brackets there, plus 8 divided by 2, everything, and now it's going to be this y value plus that y value, so it's going to be 9 plus open bracket negative 11 over 2. This setup I currently have is really awkward. Please forgive me if I sound a little bit uncomfortable, because now I'm looking at this stack of books as well. So let's simplify this. This is going to be 3. It's going to be 4 divide. Wait, what did I do wrong? So it's going to be 2 and 8, which is going to be 4. 6 here is 4. So it's going to be 6 divided by 2, which is 3, and that's going to be give us negative 1. Okay, so that's going to be the midpoint of PD. But now the only way M can lie on AC, as I've mentioned before, that the BC, BD and AC share the same midpoint, and now the only way M can lie on AC is if we maybe take the x value or the y value and substitute it in here, then we must get the other coordinate. So what I mean by that is, previously we calculated the equation of AC, but remember we are trying to figure out where the m lies on AC. So here we have the equation of AC. So I'm going to use this, and then I'm going to substitute this value, the x value or the y value, into this equation to see if I'm going to get the other value. So this is what I mean by that. So I'm going to substitute in the x value. So it's going to be y, open bracket, half, the x is 3 minus 2.5, and then I'm going to get a y value of -1. So as you can see, if I substitute an x of the x value in my original equation, then I'm going to get -1, which is here. So now you can do exactly the same for, you can substitute in -1 here, and then you're still going to get the other x value of 3. If you didn't get it, then obviously it means that m doesn't lie on AC. So that means this coordinate m lies on AC. And that's your final answer. I'm going to run through this equation again. You don't have to worry. Just have a look at it and let me know if you have any question or any line in this. You got 3 minus 1 as the midpoint. Okay, so let's look at the question again. Here they ask us, we need to determine whether M lies on AC. And the only one of the ways that we can do that is by, obviously it should be true that this and this share the same midpoint. Okay, so first of all we need to calculate the midpoint, and we use the midpoint formula, as you can see. Okay, so we can substitute in, I substituted in BD, those values, there we go. And then I got 3 and -1. So now to prove that this M lies on AC, we need to substitute either your X value or your Y value into the equation of AC. We already determined that in the previous question. So if we substitute in X, then we're supposed to get -1. If we substitute in this -1, we're supposed to get 3. Okay, so yeah, I substitute in x equal to 3, yeah, and then I get a value of -1, which correlates with this -1 here. So that means M lies on AC. If you substitute in -1 in here and solve for x, then you're supposed to get 3, okay, for your x value, and then it means M lies on AC. So it's really up to you. This one is worth 4 marks. Okay, so let's move on to the next question. Just gonna turn my page. I'm doing it really slow because I'm using a MacGyver setup here. Okay, the next one is calculate. Wait, first 3.3, they ask us to prove that BD, so here we have BD, we need to prove that this line is perpendicular to this line here. So this line is perpendicular to that line there. So if we draw an invisible line, I'm just going to draw an invisible line. If we draw a line there, okay, we need to prove that this line is perpendicular to that one. Okay, so there should be a 90 degree there. There should be a 90 degree. I'm just going to draw it like that. Okay, so I'm going to give you a few minutes. This one is worth 3 marks. Okay, we had this question here. We need to prove that BD is perpendicular to AC. Okay, if you have the answer, you can double tap the screen, or you can just give me a thumbs up, or you can God, this thing didn't charge. Okay, let's get it. We need to prove that BD is perpendicular to AC. So the first thing, it's two lines. What do you know about two lines? If they are perpendicular to each other, or perpendicular to each other, then it means if we multiply those gradients, we're supposed to get negative 1. Okay, so the gradient of AC, we already calculated the gradient of AC in question 3.1. So this is going to be 3.3. Let me just do this. Okay, there we go. So it's 3.3. So we need to prove that BD is perpendicular to AC. This is what we need to prove. And in order for them to be perpendicular, then the gradient of this multiplied by the gradient of that must be equal to -1 as stated. Now in the beginning, we already calculated the gradient of AC. The gradient of AC was, what did we get for gradient of AC? It was -2. Okay, so that's the gradient of AC. What is the gradient of BD? So the gradient of BD, so it's BD. So it's going to be this value minus that value, okay, and this x value minus that x value. So it's going to be 9 minus a half, -1/2 over -2 minus 8. And that's going to give us -2. What was the gradient of AC? The gradient of AC, I think I'm messing up. Half, it was half, excuse me. It was 1/2. Okay, the gradient of BD is -2. So in order for this to be perpendicular, if we multiply this, we're supposed to get -1. Okay, so that means the gradient of AC multiplied by the gradient of BD equal to, we must get this. So what is the gradient of AC? It is 1/2 multiplied by the gradient of BD, which is -2, which is going to give us -1. And this is our final answer. That means BD is perpendicular to AC. Okay. So I'm going to run through this question again, or this answer. If you have any questions, you're more than welcome to ask. And I know I've apologized a few times before, but the setup, I'm testing out this new setup that I'm having, which is challenging. Usually I do it on a whiteboard, okay, but now I have my cell phone in front of my face with a stack of books and a ruler, trying its best to support my phone. Okay, so let's run through this question again. They ask us to prove that BD is perpendicular to AC. Okay, so there should be a 90-degree triangle, and like I've mentioned many times in this live session, that the previous answer, 99.999% of the time you're going to use it, and it must be correct. Otherwise everything after that will be incorrect. Okay, so we need to prove that BD is perpendicular to AC. And then I said, okay, in order for that to be perpendicular, we need to prove if we multiply this gradient and that gradient, we should get -1. So previously we already calculated the gradient of AC in question 3.1 and we got a half, and the only thing we needed to calculate now is the gradient of BD. So the gradient of BD, you use these coordinates, anyone can be x2 and y2 and y1 and x1, but you need to substitute it into your formula. You get -2, and we're supposed to get this. Okay, so if we multiply the gradient of AC, there we go, and the gradient of BD, this is supposed to be BD, which is -2, then we get -1. That means BD is perpendicular to AC, and this is your final answer here. Okay, let's see if there's any questions. Thank you very much for sharing, Bassi. Make sure that you double tap the screen and share this live. It is a bit rusty today, but I haven't done a live in a very long time. I see people give roses and lions. That never happened before. Please don't give me roses and stuff like that. Just double tap the screen and share this live. Okay, so next question, 3.4. They ask us to determine the theta value. Okay, so they want us to determine this angle here, which is also called the angle of inclination in this, which is the angle of inclination, by the way. So between B and D. So theta, the angle of inclination. This one is worth 2 marks. So that will be your 3.1.4. I'm just going to leave this page here. So the first question is 3.4.1 theta, the inclination of BD. So inclination of BD. Okay, so I'm going to scroll the page like this so that you can see those values BD there. No, it's not blue. It's working. Okay, so this one is not that difficult. They ask us to calculate the angle of inclination, or theta, the angle of inclination, and the way to do that is by also using the formula that say, so this is 3.14.1, let me just do this, so 3.14.1, so the angle say, take tan of that theta value equal to the gradient of whatever the line, in this case the line is going to be BD. Do we have the gradient of BD? Yes, we calculated that in the previous question, and the gradient of BD was -2, so it's going to be tan theta equal to -2. So remember, this is now a little bit of finding the angle stuff that you've learned in grade 10, where you just need to type in your calculator shift tan of 2 and not -2. So it's going to be theta value is going to be equal to 116.57. If you have any questions, link to that one, please let me know. But like I said, this is grade 10 stuff that you've done in grade 10. finding angles under the section trigonometry chapter. So let's look at the next question. Okay, let me just give you a few seconds. If you have any questions, you're more than welcome to ask. And don't forget to double tap the screen. It will help a lot to get the stuff in every grade 12 learner's face. Okay, so the next question, calculate the angle CBD, the size of CBD. So CBD, so yes, CBD. So they want this angle here. What is the value of that angle, CBD? And this one is worth 3 marks. Okay, so we're busy with 3.4.2. Calculate the size of C angle BD. Give you a few minutes to do this one, and then I'm going to jump into it, explain you what I think how we should do that one. 3.4.2, and there is 2 ways that you can do this. Okay, so just because you see me doing this one way doesn't mean that yours is incorrect, but you're also more than willing to ask, more than welcome to ask if yours is correct, your method. I'm going to give you a few minutes to do this one. If you have the answer, you're more than welcome to double tap the screen, or you can just also share it. It will help a lot to get this live into many faces. I have random days where I do these things based on my schedule, so I can't make promises. Like I did it yesterday, okay, but I let everybody know that we're going to do a live today, but I can't promise that I'm going to do it tomorrow. Okay, so many ways to do this one. So they ask us to calculate the angle CBD, so this angle here, okay? Now, if I look at this triangle here, BCD, BCM, or yeah, if I look at this triangle, let's say B till there till A, I already have, there's a reason why they ask us to calculate this, because like I've mentioned many times before in this question, like this question, this angle of inclination that we calculated here is linked to the next one. So here I have this one, but now maybe I can also get this one here, because if I have this one, I can use one of my grade 8 statements that say this angle is equal to the sum of these two. So exterior angle is equal to the sum of these two angles. Okay, but now the question is there a way to calculate this angle here? The answer is yes. I can get that angle by using this gradient here. And can I determine this gradient? Yes, because I have these 2 points. So this is the order in which I'm going to do it. I'm going to calculate this gradient, and then I'm going to determine this angle of inclination here. And then one of my statements that I've learned in grade 8 say this angle is equal to the sum of this one and that one. So let's do that here. I think I'm going to have enough space here. So I'm just going to shove my book up a little bit. The first thing that I'm going to do is I'm going to determine the gradient of BC. So let's determine the gradient of BC. This is going to be 3.4.2. So let me just do that. 3.4.2. So the gradient of BC is going to be 9 minus 4 over -2 minus 3, and I'm going to get 13 as my gradient. So the gradient of BC is 13. So this gradient here is 13, but we're not looking for the gradient. We're looking for the angle of inclination. So that means tan of theta, let's call it beta. So let's call this angle here angle beta, okay? So that is equal to 13. And if we type that in our calculator, then we're going to get beta is equal to 85.6 degrees. 85.6 degrees. So this angle here is, let me use pencil. This angle here is 85.6 degrees. So now it's easy to calculate that, because the statement that we've learned in grade 8 say that this is equal to this plus that. So that's exactly what I'm going to write down. So theta is equal to this one plus that one. Oops. So theta is equal to beta plus that angle CBD that we're trying to calculate. But we're looking for CBD, so that means angle angle BD is equal to beta minus theta. Excuse me, theta, let me just put the minus there and plus. So it's theta, the theta is there, I'm just taking that to the left side. So my beta is going to be negative 85.6 plus my theta value, I already calculated it. There's at 116.57. So that means my angle BD is equal to, I already typed that in my calculator, it's going to give us 30.97 degrees, and this is my final answer. Okay, so just have a look at it. I'm going to run through this question again, or this answer. Don't worry, guys. It's really challenging the way I'm writing now, because the stack of books, I'm being really careful. It's uncomfortable. If you have any questions, I'm trying to look at my laptop as well, because I have TikTok on my laptop to see if I miss anything. Thank you for sharing. Double tap the screen and share. That's going to help a lot. A lot of students is going to see this live. Okay, so let's run through this question again and this answer. So here they ask us, what is the angle? What is the value of this angle here? Okay, and as I've mentioned many times in this lesson, that the previous question or the previous answer, when it comes to analytical geometry, most of the times your next question success is going to depend on the previous answer. If that answer is incorrect, your next question and everything after that will be incorrect as well. So in this case, they ask us now, what is the value of this angle here? And then I said, okay, maybe if we can get this angle, there's many ways you can do this. I've done it one way, okay? So I said, maybe if we can get this angle here, okay? Remember, this wasn't here, okay? So then this will be according to one of my grade 8 statements or theorems that say the exterior angle is equal to the sum of the interior. So this one is equal to the sum of those two. But now the question is, can we get this angle? It's yes, we can get it by calculating the gradient. Then we determine the angle of inclination. So if we have this one, and then this will be equal to that and that. So the first thing we did was determine the gradient there. Because I'm just, my cell phone is showing that it's not charging. Just give me a minute. Okay. 9%. Okay, so yeah. The first thing I did was calculate the gradient of BC. So I calculated the gradient of BC, substitute these points into my gradient formula. There's my gradient formula. Excuse me, the values that I've substituted into my gradient formula. I got my gradient BC equals to 13, but we're not looking for the gradient. We're looking for this angle, called also the angle of inclination. There's a special formula that says tan of theta is equal to this gradient here. So that's what I did. And then I just grade 10, finding the angle, we say shift of 13, and do your calculation, you get the beta value is equal to 85.6. So this angle here is equal to 85.6. Now we can determine this angle here, because there's a grade 8 statement that say the exterior angle is equal to the sum of this one plus this one. So that's what I did. I just wrote it down mathematically. There we go. So I said theta. Yes, my theta is equal to that plus that. So it's beta plus the angle C, angle BD. But I don't want theta. I rearrange my formula a little bit. I just put CBD on the left side and everything on the right side. And then I have this value, there's 85.6, so then I substitute it in, and my theta value is this, and there we go. And then I just typed this in my calculator, I got 30.97, and this was my final answer. Okay, so let's look. Okay, somebody asked, how does the Marcus know what angle you're talking about since you called it beta? No, because I, in this case, this is this is between us. Okay, so you can say B, but then you need to indicate it on your graph. Okay, who's asking this question? TTK underscore IGL, because you're determining the angle of inclination here. You can just say tan of theta. In this case, I said tan of because what else are you going to say here? There isn't another my page is here. There isn't another point there. Okay, so beta would be the, I won't say the perfect thing to do, because they didn't indicate anything in this question paper that there is a point B or X or whatever the case might be. But if you can draw the graph and maybe show it on the graph, then it will work. But let's say, for instance, it was a point, then you can say CB. Let's say that was S, so it would be S A or something like that. But this is the most clearest way that you can do. Okay, hopefully that answers your question. Okay, so I think I explained that one. So the next one is, this one is quite boring. They want us to calculate the length of AC. Calculate the length of AC. Let me just do this. Okay, that will be 3.4.3, 3.4.3. We need to find the length of AC. See, calculate this length, so it's going to be distance formula really boring question, but we have to do it. There's no way. So I'm going to give you a few minutes. Let's do this. Let me do this again. Okay. This one is worth 2 marks. Calculate the length of AC. Okay, 3.4.3, if you have the answer, you're more than welcome to comment, or you can just double tap the screen if you have it. I won't be able to see it on my laptop, where I'm not streaming from, but I'm looking at my laptop to see if there's no errors and stuff like that. Or comments, excuse me, comments. Okay, so length of AC, so it's that and that. We're going to use length, distance, the same thing. So the formula say AC is equal to square root of x2 minus x1, and we square that, plus y2 minus y1, and we square that. Okay, everything under the square root symbol. Once again, this can be x1, y1. This can be x1, y1, and this can be x2, y2. It's really up to you how you want to do it. It's going to give you the same answers. So it's going to be, I'm going to say this is going to be my x1. So it's going to be my x2, it doesn't matter. 7 minus negative 3, close the bracket, close it, square it again, plus open. So it's going to be 1 minus 4, close the bracket, everything under the square root symbol. I'm gonna get square root of 125. I'm gonna leave it like that. If you want to, if you're gonna sleep better tonight, you can also simplify it. You can type the stuff in a calculator, it will pop out like this, and that will be your final answer. That is worth 2 marks. Final question. I'm not gonna go through this one again because I think we might run out of time. The final one is worth 5 marks, and they want us to calculate the area of ABCD, so the area of this whole quadrilateral. Okay, they want to determine the area of this whole quadrilateral here. So I'm going to give you a few minutes to do that one, and then I'm going to jump into the solution. So the idea or the advice I have, I think the most important thing that I've shown here and that I've probably repeated through every question is that your first answer must be correct. And this analytical geometry is quite a lot of marks. So other thing I want to mention also here is that most of the students struggle with this, specifically with this and Euclidean geometry, is because they forget the grade 8 stuff. I've shown here, I think it's the previous question 3.4.2, where we calculate CBD, the size of CBD. That's where we use a grade 8 theorem or statement. So as you can see, all of this stuff goes together. So you must know your theorems, the FU, NX, alternate, corresponding angles, all of those things, alternate angles, all of it. And properties of quadrilaterals in your 2D figures. Okay, if you have an answer here, you're more than welcome to give it to me. You can comment the answer, or you can just double tap the screen. I'm going to give you 1.5 more minutes, and then we're going to kick off with my solution. Also, in general, if you have any other questions, you can just comment. I do have a playlist here on my TikTok. You can just comment on one of the videos, or there's a Q&A as well. I think it still exists. If you have any other questions you want to ask, or an example that I should do, most of the stuff that I've posted is examples or tips in general, and then I'll try my best to answer it as well. More seconds. 30 more seconds. Okay, so let's get into the answer. This is the final one. Let me see. I'm gonna shrink it a little bit like this. Okay, they ask us to calculate the area of the quadrilateral. There's no formula in grade 12 syllabus, depending which country. Well, I'm busy with this paper, so I'm talking about you that's in South Africa. There's no formula that you can use to determine the specific. There is a specific formula, but in your syllabus it's not dealt with. You can just plug it in and then you calculate the area of the rectangle. But what we can do is we can say, because we calculated previously, let me see, we showed that this is 90 degrees. This is perpendicular to this. This is 90 degrees, in other words. What we can do is we can calculate the area of this triangle here and multiply by 2, because this and that's obviously the same. Okay, so if we can calculate this area here, we can get this one as well, and then we add it to these two areas together. Okay, so, or you get 2 multiplied by this, then you get your final answer, in other words. So what I'm going to do is, the first thing that we need is, obviously we're going to calculate this area of this triangle here. But obviously, as you know, there's a special formula that we can use to calculate the area of a triangle. It is half base times the height. So we the base, we still need to calculate the base, and we also need the height. So I'm going to calculate BM, which is going to be my height, okay, because we already have, let me see, we already have AC. As you can see, we have the AC value here, okay, the base value. So we still need that BM value there, the height. So as you can see, the previous answer was important that you get it correct. Okay, so we first need to calculate the length of BM, because that is going to be my height. So BM, why did I wanted to write it? You see, let me just scratch this out. I don't know why I did that. So BM, so as I've mentioned, we already calculated these coordinates. Those coordinates, we calculated it. I forgot what it was. Just see. Okay, I needed that M 3 and -1. Okay. Okay, so this is 3 and -1. Okay, so now we can use it into my formula, distance formula. So I'm not going to write the formula down again. I'm just going to substitute in these values. Okay, remember those values. Your B is -2 and 9, and my M is 3 and 1. So I'm going to substitute it directly into the formula. So it's -2 minus 3, and everything is squared, and we add it to 9 minus 1, and everything is squared. Okay, everything is under the square root symbol. We get B value of square root 125. Okay, so this is our height. So now we have the height. We already calculated the base, which is AC. So the formula, so area of triangle, this is a triangle ABC, will be half base times the height. Okay, so that means half, my base is square root 125, square root of 125, and then we get value of 62.5 square units. Okay, but we're not looking for the area of ABC. We are looking for the area of this whole quadrilateral here. So it's going to be 2 times this area, because this area and that one is exactly the same. So I'm going to say okay, I'm going to run through this question again, the answer. Okay, so it's going to be, that means area of ABCD is equal to 2 times area triangle ABC. Hopefully you can see that. So that means it is equal to 2 multiplied by 62.5, and that's going to give us a final answer of 125 square units. Guys, I'm going to run through this question again, because I think you didn't maybe see this clear here at the bottom. Okay, so let's do it again. Let me run through this question and also through the answer. So here the question was, what is the area of ABCD? Okay, what is the area of this quadrilateral? So like I've mentioned, there is a formula that you can use, but it's not in your syllabus. We can calculate the area of this quadrilateral. But what we know is this area here and this one is exactly the same. So maybe if we can determine the area of this one or this one, and then we can just multiply by 2. Now in the previous question, there was a reason why we calculated the length of AC, because we can actually calculate the area of this triangle here. We have AC, which is the base of this triangle, but we still need the height of this triangle, so we still need to calculate BM. Earlier in this question, we calculated M, which is also the midpoint of BM and AC, and we're going to use the length. This is going to be our height, and also we're going to use now our length or distance formula to calculate this height here. So that's what we did. Let me just now be very careful here. There we go. We calculated BM, which is the height of the triangle. We got square root of 125. Now we can calculate the area of BCA or ABC, because it's going to be half of the base times the height. So it's half of the base. We already calculated the base before. It was square root of 125, and the height we calculated. We substitute those values in there. We get the area of ABC, triangle ABC. But we're not looking for that. We're looking for the area of ABCD, which is the quadrilateral. So it's just going to be 2 multiplied by the area of ABC. And we got 125 square units, which is the total area of this quadrilateral. Okay guys, I have to go now, but if you have any questions, like I've mentioned, don't forget to drop a comment. I think there's a Q&A in my profile that you can just tap on and ask questions. We can comment on one of the grade 12 videos that I've done. It's in a playlist. But I'm going to give you 4 minutes. If you have any questions, I still have 4 minutes left. Thank you very much for the panda. Thank you very much. I'm not sure what's that supposed to mean, panda. Thank you, Tarina Paul X. I hope I pronounced your name correct. I will make an announcement, but it will definitely not be tomorrow. A lot of stuff to do. Hopefully tomorrow is Wednesday. If you have any other questions, please ask. If you maybe wanna, because the next section, I really planned like 5 questions for the day, because I know usually the max is 2 or 3, 2.5 questions from a question paper, but because of we struggled a little bit with the setup today also. Like for those who don't know, like I have a stack of books on this side here, like it's right in front of my face, and then between the stack of books is a ruler. I'm not sure if you can visualize that, but I will make a TikTok and then post it. And then also, yeah, so the cell phone is in same height as my face. Like I'm looking directly in my face, but it's so challenging, so weird. Okay guys, thank you very much for watching. I have to go now. I will try to post this on TikTok if TikTok allowed me now, or if they gave me. I think I should actually show you. There we go. Oops. I just want to show you the setup. Okay, so here's the book, and here's the stack of books in front of me, and here's the ruler, and my charge is also there. So it's basically like this. This is what I see in front of me. See you guys tomorrow. Thank you very much. Bye bye. Bye bye bye.